Assalamualaikum warahmatullahi taala wabarakatuh dan salam sejahtera semua. Okey, jumpa lagi dalam video kali ini. So, kita akan sambung perbincangan penyelesaian soalan untuk skor fizik set 3 bagi topik 7 hingga 9, iaitu soalan nombor 6 hingga soalan nombor 8. Okey. Question number 6A. Figure shows a 2 kg block attached to a spring on a frictionless surface. The block is pulled to the left from point B to point A and released at time t is equal to 0. Then oscillate between point A and C with 40 cm. The block takes 40 seconds to make 20 oscillation. First, you need to determine the period of this oscillation. So, to calculate the period, because of the block take 40 seconds to make 20 oscillation, we divide 40 to 20, you will get the period is equal to 2 seconds. And number 2, you need to determine the amplitude of this oscillation. So, to determine the amplitude, we refer to the distance from point A to C. The amplitude is represented from point B to C or A to B. Because of that, we just divide 0.4 meter to 2 divided by 2. And then you will get the amplitude is 0.2 meter. And question number 3, you need to calculate the spring constant. Spring constant is represent K. So the equation that relate to the spring constant is the equation for period of the mass spring system, which is T is equal to 2 pi sir M over K. You substitute the T and M, mass of the block, and when you calculate, you will get the spring constant K is equal to 19.74 Newton per meter. Question number 4. You need to write down an equation that describes the position of the mass as a function of time if starting from equilibrium position B at time t is equal to 0, meaning that the block start from point B, oscillate from point B. So, before you write down the equation, you're supposed to know the general equation for this situation, and this is the mass spring system oscillation in the simple harmonic motion. Because of that, our general equation for the simple harmonic motion displacement equation is y is equal to a sine omega t. Referring to this equation, you need to substitute the value of a and omega. So first identify the a and omega. And previously we have calculated a, which is a is equal to 0.2 meter. And for the omega, because of we know the value for t, we have calculated earlier the t. So just substitute the t, which is equal to 2 seconds. You will get that the omega is pi radian per second. When you know the value for amplitude and omega, the angular frequency, substitute in the general equation of the simple harmonic motion displacement equation and write down the unit where y is in meter and t is in second. For question number 5, you need to determine the maximum speed of the block. So to calculate the maximum speed of the block, the equation for V max is A omega. And our amplitude is 0.2, our omega is per radian per second. You will get that the maximum speed is 0.63 meter per second. And the last question for question 6A is, you need to determine the amount of energy of the oscillating system. Amount of energy meaning that it is referred to the total energy of the simple harmonic motion. Because of that, the equation for the total energy for the simple harmonic motion is E is equal to half m omega square A square. Substitute the value for mass of the block, which is 2 kg. Our omega is pi and our amplitude is 0.2. You will get that the amount of energy or the total energy of this simple harmonic motion is 0.395 joule. Question 6b. A progressive wave propagates by equations y is equal to 6 sine 4 pi t over 4 plus 2x, where x and y are in meter and t is in second. Before we determine the values here, we need to expand the equation. So our progressive wave equation is actually equal to 6 sine pi t plus 8 pi x. Now we can determine the amplitude because of referring to our progressive wave equation. Amplitude is equal to 6 meter. And for the period, we know that we have the omega, which is equal to pi. So our period is equal to 2 pi over pi. You get that the period is 2 seconds. And the third equation is, the third question is, you need to determine the velocity of the progressive wave. For the velocity, we know the equation is equal to f lambda. Our f, because we have t here, so our f is 1 over t. Lambda is equal to 2 pi over k. K is the wave number. We substitute the value for k, where we get from the equation, k is equal to 8 pi. And then t is equal to 2 seconds. You will get that the v, the velocity of the progressive wave is 0.125 meter per second. But take note, the question asks you to calculate the velocity, so you need to mention the direction of the wave propagate. Because of referring to the equation, pi t plus 8 pi x plus, meaning that the wave propagate in the direction to the left. For question number 6C, you are given a closed air column of 0.8 meter long. When the sound source with the speed of 344 meter per second is placed near the open end, stationary wave is generated in the air column. Before we determine the frequency for the first overtone, just to recall back what is closed air column. So if you refer to this figure, closed air column is represent the pipe with the closed one end and open at another end. So at the closed end, it is node will produce, and at the open end, the antinode will produce. And for the closed air column, it is a odd harmonic. Because of that, n is equal to 1, 3, 5, and so on. So to determine the frequency for the first overtone, we know that for the fundamental frequency, n is equal to 1. And for the first overtone, after the fundamental frequency is the first overtone, so n is equal to 3. Because of that, to calculate the frequency for the first overtone, you need to use the equation of Fn equal to Nv over 4L, referring to the closed air column. And then substitute the value for n, which is 3, V is 344, and L is 0.8. You will get that the frequency for the first overtone is 322.5 Hz. Question number 2, to sketch the stationary waveform for this first overtone frequency. So we know that if fundamental frequency, it is one harmonic shape. So if for the first overtone, there are 3 harmonic shapes. Because of that, the stationary waveform is as shown. Question 6D. The frequency of a police car siren is 1800 Hz when at rest. What frequency do you detect if your car with a speed of 30 meter per second moving toward the police car? Assume that the speed of sound is 343 meter per second. Okay, first we recall back. What is Doppler effect? So here are the Doppler effect equation, which is Doppler effect equation is about the frequency, apparent frequency, which is the frequency heard by the observer, referring to the relative motion between the source and the observer. So referring to the question, our observer is moving towards the stationary source, which is police car. So we know that Vs, source, police car is the source, sound source. So Vs is equal to 0 and V naught is 30 meter per second. And for the sign, you need to choose either plus or minus. So for the sign, we refer to the OS concept. Observer is moving toward the source, so we will use the positive sign. Because of that, our Doppler effect equation is actually equal to V plus V naught over V times with the Fs. And when you substitute the values given, you will get that the apparent frequency or the frequency that you can detect if you are in the car moving towards the police car is equal to 1957 Hz. You can check either your answer is logic or not, because of the observer is approaching the siren, the source, so the frequency is supposed to be higher compared to the frequency of the source. So your answer is logic. Question 7a. An aluminium wire with diameter 1.5 mm is suspended from a rigid support with a load of 150 kg attached to its lower end. If the wire becomes 5.5 meter long, what is the initial length of the wire? Given the Young modulus of the aluminium is 7 times 10 power of 10 Newton per meter square. So referring to the given information, diameter D, which is 1.5 times 10 power negative 3 meter, will give you the hidden info, which is the cross-section area of the aluminium wire. Because of that, we can calculate the cross-section area of the aluminium, which is equal to actually pi r square. By r is equal to d over 2 square. That's why our A is equal to pi d square over 4. You substitute the d and you will get that the cross-section area for the aluminium wire is actually 1.77 times 10 power negative 6 meter square. Now, we want to calculate the initial length of the wire. Actually, you can refer to all given information that you have listed here. And we have the Young modulus, so you can refer to the Young modulus equation. Young modulus is actually stress over strain, and stress is F over A, strain is delta L over L naught. Because of that, Young modulus will be equal to F L naught over A delta L. And when you substitute the value of your modulus, the value of F is actually mg, and delta L is actually L minus L naught. And when you substitute all the values given to you in the question and also the hidden info just now, which is A, you will get that the L naught, the initial length of the wire, is 5.44 meter. Question 7b. Two bars of the same diameter but different material are joined end to end as shown. One end of the bar is kept at 80 degrees Celsius while the other end is at 5 degrees Celsius. Determine the steady state temperature at the interface of the bars if the length of the first bar is twice that of the second bar. Okay, given the thermoconductivity for the first and second bar as shown. Okay, first we identified few hidden information such as because of both bars have same diameter, so A1 is equal to A2. And then the steady state temperature is actually Tj. So we want to calculate the junction temperature. And also the length of the first bar L1 is equal to twice, meaning that 2L2. Okay, referring to the concept of steady state, we know that the rate of heat transfer through the first conductor is equal to the rate of heat transfer through the second conductor. And then we write down the equation that relate to both conductor, both rate of heat transfer. And then there are few things that we can cancel. For example, A1 and A2 for both sides is equal, so we can cancel. And then because of L1, when you substitute, L1 is equal to 2L2. So we can cancel the L2 also. So when you cancel the L2, and then you calculate, you have substitute the K1 and K2, you will get that the steady state temperature or the junction temperature is 44.1 degrees Celsius. Question 7c. A block of gold has dimension of 0.12 meter times 0.1 meter times 0.08 meter at a temperature of 30 degrees Celsius. If the temperature increased to 120 degrees Celsius, determine the change in the volume of the gold block. Given the coefficient of linear expansion for the gold is 1.4 times 10 power negative 6 degree per degree Celsius. Okay, firstly, this is all the information given. For example, we know that from the dimensions given, the volume, the initial volume for the gold block is equal to 9.6 times 10 power negative 4 meter cube. And then we want to find the delta V, which is change in volume, and referring to the coefficient of linear expansion, because of actually this gold block will expand, will go through the volume expansion. So we need to find the coefficient of volume expansion for the gold block. So the relationship is coefficient of volume expansion is equal to 3 alpha. So alpha is 1.4 times 10 power of negative 6. Because of that, we get that the coefficient of volume expansion is 4.2 times 10 power of negative 6 per degree Celsius. And then, because we want to find the change in volume, we refer to the equation for the volume expansion. Delta V is equal to gamma V naught delta T. We substitute the value for the gamma V naught that we have calculated and the change in temperature. You will get that the volume expansion for the gold block is 3.63 times 10 power negative 7 meter cube. Question 8a. A sample of oxygen gas of mass 7.3 times 10 power of negative 26 kg is placed in a container. Calculate the root mean square speed of the molecules of the oxygen gas at 20 degrees Celsius. Given the molar mass of oxygen is 44 gram per mole. Okay, firstly, list all the information given from the question and identify, for example, molar mass given in the gram per mole, so you need to change to the kilogram per mole. Then, to calculate the root mean square speed, the equation involved is, because of given the molar mass, so it is easier for us to use the equation for the root mean square speed that relate to the molar mass, which is 3 RT over M. And when you substitute, R is the molar gas constant, which is equal to 8.31, and temperature, so because of this is single T, if single T, you need to change to the SI first, which is 293 Kelvin, substitute the value, and also the molar mass in kilogram per mole, you will get that the Roth mean square speed is 408 meter per second. Question 8b. A 0.9 meter cube tank contains 2 mole of helium gas at 28 degrees Celsius. Okay, so referring to the question, there are two hidden info here. Helium gas, it is a monoatomic gas, so degree of freedom F is equal to 3. And then the temperature given is single temperature, so you need to change to the SI unit, which is equal to 301 Kelvin. By assuming that helium behaves as an ideal gas, you need to determine the total internal energy of the helium gas. So for total internal energy, the equation that you need to use is U is equal to F over 2 nRT. And our F is referred to the degree of freedom, which is depends on the types of gas, monoatomic, diatomic or poly. So in this case, helium is monoatomic, so F is equal to 3, 2 mole of gas. And then R is the molar gas constant, and temperature is in the SI unit. You will get that the total internal energy is 7.51 kilojoule. Then you need to determine the average translational kinetic energy of each molecule. So for the average translational kinetic energy, actually, you can use the equation 3 over 2 kT because of for each molecule. Then you substitute the value for K. K is the Boltzmann constant, and T is single T, so SI unit 301 Kelvin. You will get that the average translational kinetic energy of each molecule is equal to 6.23 times 10 power negative 21 joule. Last question, which is question 8c. A gas system with an initial volume of 2 meter cube is compressed with a constant pressure of 25 kilopascal. Calculate the final volume of the gas if work done on it is 5 kilojoule. Okay, take a look at the question and identify the hidden information. Firstly, we know that we want to calculate the final volume, so V final. And then work done on it. Work done on it meaning that the work done is negative. Work done on the system. So it is negative 5 kilojoule. Because of that, when we want to calculate the final volume, we know that this is constant pressure process. So if constant pressure, it is isobaric. We will use the equation for work done for the isobaric process, which is equal to P V final minus V initial. And our work done, you're supposed to substitute the negative sign because of the work done on the system. And the initial volume is 2. When you calculate, you will get that the final volume is equal to 1.8 meter cube. Do the answer logic? Okay, take a look here. It stated that the gas system is compressed. Compressed meaning that initial volume is greater compared to the final volume. So your answer is logic. Okay, that's it for the solution discussion for SCORE Physics Set 3 for this semester. So, thank you for listening, and I wish you good luck and all the best for your PSPM.